Hello everyone, you're welcome back again. We're going to solve for the value of x from this exponential equation. We're given that 5 raised to the power of x is equal to 80. So if you look at both the left and the right hand side of this equation, there's no way we can make the base to be the same. So therefore, we're going to apply either ln or log of both sides. So when we take the log of both sides, the left hand side will be log of 5 raised to the power of x, which is equal to the right hand side, which is going to be log of 80. So the next thing we're going to do is to recall power property of logarithm. This x as a power is going to go back to multiply the log. So when we apply that property, it's going to be x multiplied by log of 5, which is going to be equal to log of 80. So the next thing we're going to do, since we are looking for the value of x, we're going to divide both sides by the coefficient of x in the left hand side, which is log 5. So we divide the left hand side by log of 5 and also do the same thing to the right hand side, which is by log of 5. So that this log 5 will cancel this log 5. In the left hand side, we are left with just x, which is equal to log of 80, then divided by log of 5. So now we have x to be equal to log of 80 over log 5, but we're not going to stop at here. We're going to simplify this right hand side to its lowest form. So we're going to record that this 80 here can also be written as 5 multiplied by 16. So we're going to transfer 80 into what? X, which is going to be equal to log of, in place of 80, we replace 5 multiplied by 16, then everything all over log of 5. So the next thing we're going to recall is one of the property of logarithm. We see that when we have log of a multiplied by b, this is can be simplified as what? Log of a plus log of b. So this is the property we're going to apply to the numerator in the right hand side. As you can see, a represents 5 while b represents 16. So when we apply that property, so we are going to have x to be equal to log of 5 multiplied by 16 in this form is going to be what? Log of 5 then plus log of 16. So everything all over log of 5. So the next thing we're going to do, since the denominator only have one term, so the two term in the numerator can share this denominator. So we're going to have x to be equal to log of 5 divided by log of 5, then plus log of 16, then divided by log of 5. So the next thing we're going to do here, as you can see, log 5 and log 5, the same thing divide itself is going to just cancel. Is going to give us 1, then plus log of 16. 16 can also be written as 2 raised to the power of 4. So we can break the 16 as well, 2 raised to the power of 4, then everything all over log of 5. Now we're going to simplify further. We have x to be equal to 1 plus log of 2 to the power of 4. As you can see, applying this power property of logarithm, the power here 4 is going to go back to multiply the logs. So we're going to have 4 multiplied by log of 2 and everything all over log of 5. So next, we're going to have x to be equal to 1 plus. So when we factor out this 1, 4 is going to be 4, then multiply by log of 2 over log of 5. So here we are going to recall property called changing of base property of logarithm. So we have log of 2 all over log of 5. So here we are going to recall this property called changing of base. When we have log of a over log of b, this can be also simplified as what? Log of a to the base of b. So this is changing of base property. So when we apply this property to the last term in this equation, so we are going to have x to be equal to 1 plus 4, then multiply by log of 2 over log of 5. Written in this form is going to be what? Log of 2 to the base of 5. So here is the value of x that satisfies this exponential equation. Thank you for watching, and please don't forget to subscribe and also follow my page for more video like this.